In video 1B, we're going to be using some similar polygons, and we talked about how polygons are similar if all their sides are proportional. So we're going to be using that fact to find missing sides. So we'll put a little add-on here to find missing links. So let's go talk about what we do. If two polygons are similar, remember that's our notation for similarity. We set up a proportion, aka two equal ratios or two equal fractions, proportion. All right, so let's suppose we had a couple of rectangles. Let's make the easiest thing. And I blow it up and I tell you these are similar. I tell you this is 2, this is 3, this is 5, this is, I don't know, find it. How do I find it? I set up a proportion. I grab corresponding sides and I say 2 blew up into 3 in the exact same proportion or ratio that 5 blew up into x. And once I set up that proportion, I just solve it using the methods from the last section. I say 2x is equal to 15. So in order for these to be the exact same shape, x would have to equal 15 cut in half, which is 7.5. So we're going to go use that on the next couple of examples. First one up, it says these polygons are similar. So I know that this got blown up to this and that all the sides are in the exact same ratio or they are proportional to each other. So I'm going to grab the one I don't know called question mark. I prefer to call it x. And I say x blew up into, and I grab its corresponding side, 25, in the exact same way that can't use 24 because I don't know this one over here, so I have to say 12 blew up into 15. And I have a couple options. Again, I can reduce this fraction if I want to, but if you don't like that, you can always just go right to cross multiplying. And if you have a calculator, it really doesn't matter. So I'd have 15x is equal to 25 times 12, which is 300. And then I would divide both sides by 15, and 300 divided by 15 is a nice 20. And I'm done. I found the missing lengths by setting up a proportion. On the next one, and by the way, this is used a lot for scale drawings and on maps and in architecture because most things are drawn first before they're built, and they're shrunk down and they're drawn what we call to scale, kind of like a blueprint. And then what we do is we just blow everything up by a scale factor and everything becomes built way larger exactly as it was drawn up on a scale drawing. So we've got question mark over here. Who corresponds to question mark? Well, it's the shortest side. This is the next shortest side. I like to dash them sometimes so I can see it. So I've got a short, a medium, a long. I've got a short, a medium, and a long. And I'm going to set up a proportion that'll help me find short. And I'm going to call short x. So x blew up into 35, short side of the other one, exactly the same way as, and because I've got all the lengths, I can pick either one. I just have to make sure I grab their corresponding part. If I'm going to use 48, I can't say 48 to 63. I've got to make sure I grab the middle length one and set it equal to 48 over 56. Now I do have or I could have done 54 over 63. It really doesn't matter. And again, I can go right to cross products, or I could reduce this fraction and go to cross products. I'm going to cross multiply. 56x is equal to 48 times 35, which, once you go to a calculator, is 1,680. I'm going to divide both sides by 56 to attack that x. So divided by 56 equals, and we've got a nice 30. And we're done. Again, just to repeat, this right here, I could have used 54 to 63, and had I done that, I would have still gotten the same answer because I was told that the figures are similar. So all those ratios are identical. On the next one, I was only given one pair, but I'm given the scale factor from A to B. So A to B equals 6, 2, question mark. And I just, again, 2x is equal to 7 times 6, which is 42. I divide both sides by 2, and I get an x of 21. So that's how we find missing sides on similar polygons. And now we're going to bump up the difficulty a little bit by throwing a couple algebraic expressions in the mix, but it does not change the process at all. Again, they tell me these are similar, which allows me to set up a proportion. I take 8x minus 2 and its corresponding length, the long side over there. I grab another pair of corresponding sides. I've only got this one. That's got to go on top because I'm going this way. And I put that over 49. I don't know, with all these big numbers, I really do think on this one I'm going to reduce this fraction. Again, you don't have to. You could go right to cross products. But I'm going to divide a 7 out of here and a 7 out of here and work with those instead. I'm going to do it right on here. I'm going to say 7, that cross product, times 8x minus 2. Again, I'm doing that just because I don't want to work with the big numbers. If you don't mind, go ahead and do 49 times 8x minus 2 and work with that. And then on this cross, I'm going to have 6 times 63. And I have a couple options here. I could actually divide both sides by 7 right now and go a little quicker, but I think in algebra they drill into your head to distribute, so I'm going to be consistent with what you've been taught prior to this so that you don't get goofed up. So I've got 56x minus 14 has to equal 6 times 63. Which is 378. I'm going to add 14 to both sides, trying to attack that x. It gives me 392, and that's what 56x is equal to. So I'll divide both sides by 56, and I get a nice 7. All that work, and x is a beautiful 7, and I'm done. And last of this type, I believe, is on these pair of similar quadrilaterals. They are concave. Let's go take a look. I've got this piece I'm looking for, and I'm going to grab its corresponding side, write them as a ratio, make them proportional to any other pair of corresponding sides from little to big. So I'm going to choose 18 to 24, or I could have done 27 to 36. And let's on this one not reduce the fraction, just in case you choose not to. Try to suit everybody's needs here. We'll do 24 times x minus 2 has to equal 18 times 12. And we'll distribute because that's probably what you've been told to do. So I'll do 24x minus 48 is equal to 18 times 12. 18 times 12 will yield 216. I'm going to add 48 to both sides, trying to attack that x here, and I've got 24x is equal to, and when you add, you're going to get 4, 6, 264. So now attacking that x, it's 24 times x, so I'm going to divide by 24. Oops, I clicked the sidebar there. It's not liking me writing over here, so I'm going to go up here. So I'm going to divide both sides by 24, and 264 divided by 24 will give you a final answer of 11. And I'm done. So next topic up on this video will be, is there something down on the bottom there? Let's go see what our next topic is. More similar triangles, aren't you just loving them? But although we're not going to do proofs in here, yay, right? We're going to still talk about the theorems used in proofs. So we're going to discuss the main theorems used to prove that triangles are similar. There's 3 of them, so let's divide this big content box into 3 pieces. On the top, we've got what's called the side, side, side similarity theorem. And what that says is that if you can get, if all 3 pairs of sides not sids, sides are proportional, then the polygons, I'm just going to write then polys, are similar. And I'll just use that. Another way you could get them to be similar, so you really, all three sides have to be proportional and all the angles have to be the same, but you don't have to get all 6 of that to happen. These are kind of little shortcuts. And another one is to get 2 pairs, that's why there's 2 S's on there, 2 pairs of sides proportional, 2 equal ratios, and now let's go take a look at what we've got here. When I write it like this, SAS, it means SAS. That angle has to be included or wedged between the 2 sides. We call that an included angle. So 2 pairs of sides proportional and the included angles congruent. Remember, our symbol for that is an equals with a little bar over it. Then the polygons would be similar. And last up, you don't even have to get any of the sides proportional. If you take a triangle, suppose that's 90, and I shrink that down so it looks the same, and that's 90, you'll notice that the angles I did not change. This angle is the same measure as this one. This angle is the same measure as this one. So we have what's called the angle, angle, angle similarity theorem, but we can even narrow that down and just call it the angle, angle, because if 2 angles in a triangle are the exact same measure, the third one gets locked in for free, because remember they have to add up to 180 degrees. So if you can just get 1 pair, this one's the easiest one to spot. If you can just get 2 pairs of congruent angles, then you can stop and say the polygons are similar. So we've got 3 ways that we can show that triangles are similar. And we're not going to write proofs, but you will have to state if they're similar, and then if they are, state how you know, and then it says to complete the similarity statement. So no proofs, which should make you happy, but still the same knowledge required in writing a proof. So let's go ahead and start. So of my 3, SSS, SAS, and angle, angle, this one is shouting out to me on this one because I have 2 pairs of sides, and I know nothing about the third. So I have that blue, and I've got these red, and I know nothing about anything else except I have a theorem from semester 1 that tells me vertical angles are congruent. So I actually know that pair of angles is the same. So I really do, or I'm going to try to get side angle side, but I have to make sure that those sides in question are proportional. So I've got to run a little test. Does 16 over 40, bang, bang, equal 16 over 39. Well, that's so not true, right? So these are actually not similar. I can't get the only one that could possibly work. I can't meet the criteria for similarity. So I can't complete the similarity statement because they're not similar. All right, on the next one, obviously angle, angle, right? So I would say these are congruent by angle, angle, and then I just, for my similarity statement, that's what this is, so I'm going to point at that. That's called a similarity statement. My similarity statement for this is, I just have to match the parts. J, who's J's corresponding angle on the one above it? T, because they both have a single arc. So I've got to start my similarity statement with T. Then it goes K, double arced. So I have to go U, double arced. And then lastly is L, no arcs, which has to go with V. And it matters. You have to match them up. Oops, and I forgot the triangle symbol in front. That's also important. Otherwise, it's notation for a plane. All right, so again, we've got similar triangles here, finding missing lengths. So I'm going to be setting up some proportions. But the difference is it's not always clear who goes with who. So we got to be a little careful, be a little bit more clever. Let's go find our missing part, X. and see if we can figure this out. So I've got two triangles here. I've got a red one inside that I'm going to match parts with, and I've got the blue one on the outside, and I'm going to set up a proportion with corresponding parts. But the problem with this is X isn't really part of a triangle. It's this upper piece right here. However, if X was 4, I would know this is 8 because the whole way is 12. So what I do know is that 12 minus X is the right-hand side of the red triangle. And what that's going to allow me to do is set up some proportions. I've got the right-hand side of the red triangle to the right-hand side of the blue triangle has to equal another pair of sides from one triangle to another. Well, on the red one, I know the bottom is 6, and on the big one, I know the bottom is not 18, but 24, because I have to go all the way across. So I had to be a little careful in not mistaking two things, 18 for a side of a triangle, because it's not. That's just from here to here. And I had to make sure I didn't mistake X for a part of a triangle, but once I worked it out, we're good to go. I'm going to reduce this fraction just because I don't like working with those big numbers. You don't have to, but 6/24 is really 1/4, and that makes a lot less work for me. So I'm going to set my cross products equal. 4 times the quantity 12 minus X is equal to 12 times 1 is 12. I could distribute, or again, I've told you, teachers always say you got to distribute that in, and a lot of times that's helpful, but I really could divide both sides by 4, and honestly, that makes your life so much easier, guys, so I'm going to do it on this one. I haven't done it yet because I don't want to mess you up, but it's so much easier. And then 12 minus what is 3? And the answer is 9. So X is 9, and that's the missing length. So X is 9, and I'm done. All right, let's go take a look at the next one. And we'll give that one a whirl, and then I believe we're hit a stop sign. Am I right? Yes, perfect. So then we'll be ready to go do some on the worksheet. Where am I here? Do I have 2 more? Let's just do 1 more. I think you guys get it. I don't like the videos to go too much beyond 15 minutes for you. So we'll just do this one up on top, and we'll call her a day. All right, so let's match up our corresponding parts. Again, I've got short, short, medium, medium, long, and long. And I'm going to match up corresponding parts. I'm going to start with the one that has an X in it. So I've got 11X plus 11. I'm going to put it over its corresponding part, 2 dashes, the middle length side, which is 30. So I have 11X plus 11 over 30 is got to equal, and then I need another pair of corresponding parts, short to short. So I would say 77. Just a second, somebody came to the door and I kind of lost my train of thought here. 77 over 21. Again, a couple options here. You can immediately start cross multiplying, bing, bang. Or if you're not liking this fraction and you're seeing 7s hiding in it and you'd like to knock it down, you could do that as well. It's all up to you. On this one, let's not knock the fraction down. We'd say 21 times 11x plus 11 is equal to 77 times 30. Now I challenge you to not distribute that 21 in. Go like this. Divide both sides by 21. Makes your life a lot easier. Go do 77 times 30 on a calculator and divide it by 21. And on that side over there, I get 110. And that's what 11x plus 11 equals. So I've got 11x is equal to 110 minus 11, which would be 99, right? And then I divide both sides by 11, and I have a nice x equals 9. And I'm done. So we won't do that last one. We are done with this video, and if you watched it, you'll know that I'm only going to have you do the odds on this worksheet. If you're trying to do the worksheet without watching the video, you never know when I'm going to say just odds, just evens, all that kind of good stuff. All right, and plus you got to show me the notes anyway to access a test. So have a good one. Thanks for listening, and good luck on your worksheet. Peace out, Girl Scout.